Welcome to the second video, guys. I'm gonna start off with the example that I gave in the previous video. I'm gonna give you guys the solution, or we're gonna work through it together. So now the example was like cos 180 degrees minus theta divided by sine 180 degrees plus theta plus 180 degrees plus theta. So now you guys, I think it's better that you guys, or it's important that you guys go to the diagram that I gave you in the previous video. The diagram that shows different quadrants and different functions that are positive in those various quadrants. That's going to be very important in solving this example. So we know that cos 180 degrees, that's in the second quadrant. And in the second quadrant, you know that only sine is positive, cos is negative in that quadrant. So it's going to be minus cos theta. And then going to the denominator now, sine 180 degrees plus theta. That's in the third quadrant. And we know that in the third quadrant, only tan is positive. Cos and sine are negative. So it's going to be minus sine theta plus tan 180 degrees plus theta. This is in our third quadrant. And we know that in that quadrant, only tan is positive. And then all the other functions are negative. So it's going to be positive tan theta. So now we can simplify this because we're dividing negative by negative. Those negatives are going to cancel out, and then we're going to be left with cos theta or divided by sine theta plus tan theta. And we can simplify this expression further because we know that, and let me write it here in this small space. We know that sine theta divided by tan theta equals to, sorry guys, it's sine divided by cos. That's equals to tan theta. So you know this. That means 1 over tan squared theta, or inverse of tan squared theta, is equals to cos squared theta divided by sin squared theta. So this is going to simplify to 1 over tan theta plus tan theta. That's how we're going to simplify this example. So now let's move to the content that's going to be covered in this video, or in part 2. So first of all, we're going to start with negative angles. That's going to be the first part that we're going to cover in this video, negative angles. So negative angles, you need to know that these are angles that are measured in a clockwise direction from the 0 degrees line. Clockwise direction, those are our negative angles. So let me just draw the Cartesian plane again for you guys. Cartesian plane there. And I'm going to draw, that's where we're going to have our y, our x, and then 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then we're also going to have 360 degrees at that point. So the same rules that we used in our reduction formula examples are going to apply here. So the same phrase again, all students take coffee. That means all functions are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and then in the fourth quadrant, tan is the only function that's positive. So we're going to use that phrase again. And also you need to remember that for all these angles, theta has to be less than 90 degrees. It's an acute angle. You need to remember this, guys. It's very, 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 very important. And also again, let me just show you how we measure negative angles. So like I said, negative angles are measured from the 0 degrees line going in a clockwise direction. So for the first one, let's have an angle there, an acute angle there. This angle here, this is theta. This is negative theta because it's measured in a clockwise direction from the 0 degrees line. And then we can also have an angle in our third quadrant, an angle that goes like that, and it's measured from this point going all the way to that line. And we know that this angle has to be an angle between 180 degrees and 270 degrees. So we can measure 180 degrees from that 0 degrees line. We're gonna land at this point, and then we can add, we can measure an angle in an anti-clockwise direction. You need to remember that angles in an anti-clockwise direction are positive. So now it's going to be 180 degrees plus a certain angle. That's why we're going to get this angle here from the 0 degrees. So we can put our theta there. So that means we measure an angle from 0 degrees going all the way to 180. And then from 180, we measure an angle in the opposite direction for us to get this line here. And then this angle, we can call it 180 degrees or minus 180 degrees because it's a negative angle, plus theta because we measured it. Let me just write it in its rightful quadrant. Write it here, 180 degrees plus theta because we're measuring minus 180 degrees and then we're moving in an opposite direction. So it's going to be plus theta. And then for the second quadrant, we do the same thing. We measure an angle from 0 degrees line in a clockwise direction all the way to this point or to this line. This angle is going to be minus 180 degrees minus theta because remember we're moving in the same direction. So we're coming to this point and then still moving in a clockwise direction, going all the way up to this point. So it's going to be minus 180 degrees minus theta, minus 180 degrees minus theta, because we're moving in the same direction. Unlike in this case where we moved in the clockwise direction and then we changed direction, moved in anti-clockwise direction. That's why we have a positive theta there. Yeah, let me give you, just name these quadrants 1, 2, 3, 4. Let's try to solve or to put this thing into practice. For quadrant 2, so we're gonna have, let's start off with sine 180 degrees minus 180 degrees minus theta. That's in the second quadrant. So in this quadrant, you know that the only function that's positive in this quadrant is sine. So this is gonna give us sine theta. That's how we're gonna simplify this one. And then for the second one, let's work with cos minus 180 degrees minus theta. This is in the second quadrant also. And we know that cos is negative in that quadrant. So it's minus cos theta. And then let's move on to the last function that we're going to be working with, which is tan minus 180 degrees minus theta. So it's also in the second quadrant. And we know that tan is it's positive, it's negative, sorry. Tan is negative in this quadrant and be minus tan theta in that quadrant. And then now let's move on and try to simplify functions in the third quadrant using the same diagram. Remember that this Q represents quadrant. Don't mistake it for question and whatever. It's quadrant number 3. So now in this case, let's have sine minus 180 degrees plus theta. In the third quadrant, we know that sine is negative. The only function that's positive is tan. So it's minus sine theta. And then cos minus 180. It's also in the third quadrant. In this quadrant, you know that cos is also negative. So it's minus cos theta. That's how we're going to simplify that one. And the last one, let's work on tan 180 minus 180 plus theta. Tan is the only function that's positive in that quadrant. So it's going to give us tan theta, positive tan theta. That's how we're going to solve different expressions in different quadrants using that diagram. And then the last quadrant now, we're working on the fourth quadrant. The first one, let's work with sine, and then the angle in the fourth quadrant is minus theta. So it's sine minus theta. So now this one is going to give us a negative because we know that in the fourth quadrant, sine is negative, minus sine theta. And then moving on to cos minus theta. Cos in the fourth quadrant is positive, so it's going to give us plus cos theta. And then working with tan now, tan negative theta, still in the fourth quadrant. And then we know that tan is negative in the quadrant. So it's minus tan theta. This is how we're going to simplify our different functions. Now let's move right along to trig identities. I'm just going to give you different identities that you need to know in order to simplify trigonometric expressions. Let me just write them here quickly for you. Trig identities that you need to know. These are from grade 11. You did this in grade 11. So these identities, the first one we have sine squared theta plus cos squared theta equals to 1. So you need to know and always remember that in order for you to successfully solve your different trigonometric problems. And from this same equation, you can come up with an equation that goes like cos squared theta equals to 1 minus sine squared theta. What I did there was simply I made cos squared theta the subject of the formula. That's what I did there in order for me to get this expression. And then for the other one, sine squared theta equals to 1 minus cos squared theta. I did the same thing with sine. I just made it the subject of the formula. And then now the other function or the trig identity that you need to know is tan theta equals to sine theta divided by cos theta. You need to know this. You need to always know and remember that. It's going to be very, very important when solving different trigonometric problems. I just hope you copied this. Let me write it down again so you get some time to just copy these expressions. I'll be carrying the board on this other side. Some time to copy that. Yeah, let's move right along to the last part, which is special angles. So we're going to be looking at special angles. That's going to be, I hope you've copied these expressions on this side, because I need space for us to work on special angles. Special angles. Yeah, special angles, you need to know that special angles, we mean angles such as 30 degrees, 45 degrees, 60 degrees. Those are our special angles. You need to always know and remember that. So in order for you to remember different solutions when dealing with special angles, you need to draw a Venn diagram. This diagram is Cartesian plane, where we're going to have our x and y coordinates and then different angles corresponding to different values of our x and y coordinates. X and y. So now we're going to draw different lines at different angles. Lines and different angles. So now the first line, since it's closest to this x-axis, so we're measuring, remember we're measuring these angles in an anti-clockwise direction from the 0 degrees line. So 180 degrees there, and then 180, and then 270. So now if we're measuring in an anti-clockwise direction, that means this line here will be at 30 degrees because it's our smallest special angle, 30 degrees there. I hope you can see. And then the second one will be at 40 degrees. This measuring all the way coming from the 0 degrees line to that point. That's why we're going to have 45 degrees. And then the furthest line from the 0 degrees line will be our 60 degrees. That point there, 60 degrees. So now this line, it's the same for each and every angle. So the length of this line is the same. And then when solving special angles, this line, we take it to be equals to 2 units. That means the length of this line is 2 units. We're going to refer to it as R in each and every angle. From that point, this is our 0 degrees point again. Or 0 values, 0 y, 0 x. That's our origin again. So now we need to label these points now. Starting from the y-axis and also the x-axis. So now from this point, we know that this is where we're going to have, let me just write y on this side. Y is going to be 0 at this point. 0, y. And then we're going to be measuring, it's going to be increasing by one unit in a clockwise direction from this point, from this y-axis, our y value is going to be increasing. Oh, sorry, it's going to be decreasing in a clockwise direction from the y-axis. That means this point, because it's the furthest point from the origin, it has to have the greatest value. So now let's start at this point, which is the closest to the origin. That means this is going to have the lowest value. So if here it's 0, that means here on this y-axis it's going to be 1. And then here we're going to have 2 on the y-axis. And then here we're going to have 3 on the y-axis. And then this point here on the actual axis it's going to be 4. Because our y values are increasing in an anti-clockwise direction from the 0 degrees line, or from the 0 degrees line. And then for our x values, they're going to be working in an opposite way. They're going to be increasing from the 90 degrees line, or the 90 degrees point, in a clockwise direction. That means here our x will be 0, and then our, let me just write it properly, that means x comes to the inside and then y is on the other side. So now our x is 0, and then at this point our x will be 1, because they're going to be increasing by 1 unit in a clockwise direction from the 90 degrees line. That means this point, because it's on the y-axis, obviously our x is 0. And then this point, it's a little bit further from the y-axis. That means x has to have a certain value. In this case, you're saying x is going to increase by a value of 1 in each instance. So here it's going to be 1, and then for the second point it's going to be 2, that's our x, and then for the third point you're going to have 3, that's our third point. It's the x. You need to know that all these lines come down to that point. And then for the last point of x, let me just draw it closely a bit. X 0 degrees. The last point of x is going to be here on the x-axis. That's where we're going to have the maximum x value. And we know that on the x-axis, that means our y value is 0. Then we're going to have 4, and then the y value will be 0. That's how we're going to do it. So now let me just name these points properly, and then I'm going to write the values on that side. Let's name this point here, the maximum point on the y, A, and then the second point, which is this point, let's name it B, and then the next point, let's name it C, then the other point, let's name it D, and then this last point, which is the point on the y-axis, let's name it E. So this is our D point, and then different coordinates for each and every point. Point there, and then the last point is there. So I'm gonna just write it nicely for you on the other side. For point A, that's where we're gonna have point A. The coordinates are, and again we need to take a square root of each and every coordinate for us to work with special angles. That means if we have 0 and 4 for this point, we have to take a square root for these two coordinates. That means it's going to be square root of 0 and square root of 4. So the first point is going to be square root of 0 and then corresponding to the square root of 4. And you also need to remember that when naming these coordinates, we need to first write the x coordinate, and then the one on the right will be our y coordinate. And then B, point B, which is the point there, that's where our y is at 3 units, and then our x is it's at 1 unit. That means we're going to get something like square root of 1 and square root of 3. Those are our values for x and y. And then for the third point, which is point C, this point here, our y corresponds to the value of 2, and then our x will correspond to the value of 2 also. It's going to be square root of 2 for x, and then square root of 2 for y. And then moving on to the fourth point, B. That's the point there. And then that means we're going to have square root of 3. That's our x, and then square root of 1. And then the other point, or the last point, is E. We're going to have our x is maximum. That's why we have 4, square root of 4, and then the y will be square root of 0. Those are we need to know all these coordinates for us to solve special angles successfully. Let me give you an example of how we're going to apply this special angles or these different coordinates. I hope you have copied this part. We can just we need to use a different phrase now for us to solve these special angles. The phrase goes like, oh, having another hour of algebra. So you need to know this phrase. Oh, having another hour of algebra. You need to remember it. It's going to be very important when solving problems involving special angles. These are the key letters that you need to look at. So for example, or let me just apply this to different functions. Sine is the first one. Sine, it's opposite over hypotenuse. Opposite over hypotenuse. So you need to remember this. And then cos, let me just put theta there. Cos theta is adjacent over hypotenuse. Adjacent over hypotenuse. You need to remember this, guys. It's very important. You need to remember this, these expressions when solving different trig problems. And then tan theta is the last one. Opposite divided by adjacent. Opposite divided by adjacent. Okay, just copy those expressions there, and then we're going to use them to solve different trigonometric problems involving special angles. Let me just give you some time. It's fine, I think. Hope you've covered all these expressions. So now, okay, the first one, let's work with sine 30 degrees. Sine 30 degrees. So if it's sine 30 degrees, you go back to a diagram. You look for 30 degrees. 30 degrees is this point here, from the 0 degrees line. So it's along this line. Along this line. This is our 30 degrees line. So in order for you to solve these problems with no difficulty, you just need to copy this angle. This triangle. You can see it's a right angle triangle if you draw it all the way from the origin, going up there to that point, and then down to the x-axis. And then you draw it along the x-axis. That's our right angle triangle. You need to draw that right angle triangle to avoid any confusion. Let me draw it before I can solve this. Just draw it here nicely. That's our 30 degrees. And then this is our R. Remember that our R is always equals to 2. The length of these lines is always equals to 2. So that means the hypotenuse is always equals to 2 when dealing with special angles. R is equals to 2. And then the opposite side is this one. Oh, this is the hypotenuse, by the way. And then the opposite side is here. Remember that the opposite side, just notice that the opposite side corresponds with the y-axis. If you can just project this line all the way to this point, you can see that this line is corresponding with this line of the triangle, or with the opposite of the triangle. That means our value for this length has to be our y-coordinate. Y-coordinate there. So it's going to be 1, or square root of 1. Remember, we need to square all these values when dealing with special angles. It's going to be square root of 1. And here also it's going to be square root of 2. Because we need to square all these angles. And then for the adjacent, we're dealing with point D. So that means go down there. Sorry, this doesn't have to be squared, sorry. This R is always equals to 2, by the way. Remember, I said it there. And then for the adjacent, it's corresponding with the x-axis. It's this line here. So that means our value for x, or for the adjacent, has to be this point here. And that's our x-coordinate. It's square root of 3. Square root of 3. That's our adjacent. Or we can just use this the same triangle to solve different different examples or special angles for different functions. Sine 30 degrees will be equals to opposite divided by hypotenuse. Our opposite is square root of 1 divided by the hypotenuse is 2. That means square root of 1 divided by 2. That's our sine 30. And then if you're going to work with cos 30 will be equals to cos it's adjacent divided by hypotenuse. That's going to be adjacent, which is square root of 3 divided by 2. That's how we simplify these special angles. And then for tan 30 degrees will be equals to opposite over adjacent. So let me just draw a line here to show that it's on the other side. So opposite is square root of 1 divided by adjacent, which is square root of 3. See, this is how we simplify our special angles without the use of any calculator. Thank you guys. That's all for now. Please join us in the next video. Cheers.